NASA just released the very first images of the James Webb Space Telescope, and everyone, from space enthusiasts to even those who aren't as interested, are beyond amazed by the resolution and the details the images turned out. This is the Discover Space channel, and we will walk you through the marvelous images sent by the James Webb Space Telescope, one after the other. Be sure to subscribe if you haven't already, and let's get on to the video. The first image is a deep field image of the SMACS 0723 galaxy cluster. SMACS 0723 is 4.6 billion light-years away and is home to hundreds of galaxies, including the weakest infrared objects ever detected. This deep field captured by the James Webb Space Telescope's near-infrared camera, or NIRCam, is a composite of photos obtained at various wavelengths over the course of 12.5 hours. Furthermore, due to the direction of the foreground galaxies, we witness some extremely strange gravitational lensing of light from galaxies far further out in this field. About 13 billion years to be exact. The ones that appear to have white light are the ones that are causing the lensing, while the reddish ones are the ones that are lensed. And all of these red galaxies are incredibly young, having formed only a few 100 million years after the Big Bang. Some of these galaxies are likely to contain the first stars ever created. Here is a comparison of the same exact image of the location from Hubble, and the difference is insane. In comparison to the 12 hours it took JWST to capture this image, Hubble's deep field photographs would require 2 to 3 weeks of observations on a specific spot in the sky. This demonstrates that Webb is the more efficient of the two telescopes. Not only is it larger, but it also has more sensitive telescope, capable of seeing wavelengths that no other telescope can. Next image depicts Stephan's Quintet, a well-known clump of galaxies situated in the northern constellation Pegasus, which we are pleasantly surprised by. If you zoom into this galaxy, you can see single points of light. You can actually see individual stars in this galaxy. Aside from that, the key difference between Hubble's would obviously be the resolution, and with JWST, you can see all of the gas in the galaxies, which is so helpful in examining it for science purposes, especially if we want to study the black holes in the center of all these galaxies. Now, although referred to as a quintet, only 4 of the galaxies are genuinely close together and engaged in a cosmic dance. When compared to the other 4, the 5th and leftmost galaxy, NGC 7320, is well in the foreground. NGC 7320 is located 40 million light-years away from Earth, whereas the other 4 galaxies, NGC 7317, NGC 7318A, NGC 7318B, and NGC 7319, are located approximately 290 million light-years away. This is the largest image taken by the Webb telescope to date, encompassing nearly 1/5 of the moon's diameter. The image has over 150 million pixels and was created from 1,000 individual images. The image depicts sweeping tails of gas, dust, and stars being pulled from multiple galaxies by gravitational forces. According to NASA, it is unusual for scientists to view in such detail how interacting galaxies cause star formation in each other, as well as how the gas in these galaxies is disturbed. Stephan's Quintet is an excellent laboratory for examining these fundamental processes of galaxies. The next image depicts a dying star. a planetary nebula known as the Southern Ring Nebula, or NGC 3132. It is a star ringed by gas and dust rings located approximately 2,500 light-years away and completely visible from the southern hemisphere. When stars die, they expel their gases into space, and here's a photo of the exact same planetary nebula captured by Hubble. I mean, just look at the difference in detail. Not only that, but in a different infrared wavelength, you can actually see that the star at the center is a binary star. It has a twin. We've always known it has a twin, but now, with the help of JWST, we can clearly see it. Webb has revealed the second dusty star at the core of the nebula in significantly greater detail by observing it in mid-infrared wavelengths. The star orbits its companion closely, ejecting layers of gas and dust on a regular basis. The whirling couple has collaborated to create a stunning landscape of asymmetrical shells. Webb's near-infrared light image focuses on spotlights from the stars as light travels through the holes in the dusty ejections of the nebula. The neighborhood landscape is shaped by these two stars, which are locked in a close orbit. In this complex system, Webb's infrared photos reveal new information. The stars and their layers of light are visible in the image from Webb's near-infrared camera, or NIRCam, on the left, while the image from Webb's mid-infrared instrument, or MIRI, on the right, indicates that the second star is surrounded by dust for the first time. The brighter star is further along in its stellar evolution and will most likely emit its own planetary nebula in the future. Finally, here is a view of the Carina Nebula. This is a stellar nursery, which means that this is where stars are born, as opposed to the last photo, which is a star dying. As compared to the Hubble's image of the Carina Nebula, JWST actually photographed the outer edge in high detail. Webb's image removes the cobwebs of gas and dust to reveal hundreds of previously unseen stars in the vicinity, as well as bubbles, cavities, and jets spewing out from more younger stars. The telescope's capacity to pierce the dust screen in comparison to Hubble's image is so strong that it can capture the light of galaxies far beyond the region. And we are now seeing hundreds of stars we didn't even know existed in this area. Let's just all take time and admire this amazing cosmic photograph of stars being born and maybe even have planets and life someday. Who knows? This scene of mountains and valleys dotted with brilliant stars is actually the edge of Carina Nebula's adjacent, young, star-forming region known as NGC 3324. NGC 3324, which is around 7,600 light-years away, was photographed by Webb's near-infrared cam and mid-infrared instrument. This image, captured in infrared light by JWST, exposes previously invisible areas of star birth for the first time. Webb exposes newly formed stellar nurseries and individual stars that were previously obscured in visible light images. Webb's sensitivity to infrared light allows it to see these objects through cosmic dust. Some of these young stars emit protostellar jets, which are seen in this photograph. The newest sources appear as red spots in the cloud's black, dusty section. Objects in the early rapid stages of star formation are quite difficult to photograph. But Webb's extraordinary sensitivity, spatial resolution, and imaging capabilities can document these elusive phenomena. Until now, scientists have had relatively little information regarding the impact of a large number of young and active low-mass stars. They will be able to gain a complete census of their number and impact impact throughout the nebula thanks to Webb. These NGC 3324 observations will undoubtedly shed some light in the process of star formation. As an added bonus, they released data from the atmosphere composition of the exoplanet called WASP 96b. And if you don't understand this chart, no worries. You just have to note that the detail and resolution with which they are able to capture these atmospheric elements is absolutely beyond us. They also confirmed that this exoplanet had water vapor in its atmosphere. This is just the beginning of JWST's continuous exploration and a huge step forward for mankind. Can you imagine how our further scientific research will improve and advance with the outputs yet to come by the James Webb Space Telescope? Thank you so much for tuning in with us for another cosmic discovery. Be sure to comment down what you want us to explore next, and we shall see you then.